This is a walkthrough of Problem 2 on Exam 2 of Module 12 in the book Problem Solving Guide for Electromagnetism and Optics. A double slit experiment is performed with a laser that has a wavelength of 628 nanometers. The screen is 1.2 meters away from the slits, and the slits are 0.25 millimeters apart. How far apart are consecutive bright fringes on the screen? Give your answer in units of millimeters to 3 significant digits. So let's focus on the central maximum straight across from the laser and the first maximum above the central maximum. So we can draw them in there. There's the line to the first maximum. There's the line to the central maximum. The angle is very small. Now let's zoom in on the slits. It's the only way we're going to get the angle, or at least understand how to get the angle. So the distance between the slits is 0.25 millimeters. The distance, the path difference is right here. It's one wavelength. So we can get the sine of this angle right here. Sine at that angle is the opposite side, which is the path difference, divided by the distance between the slits. Wavelength, 1 is the path difference, 628 nanometers. D is 0.25 millimeters, getting the same unit. We can calculate theta. And let's keep 4 significant digits because the answer asks for 3. This angle right here is very close to the angle from a point that goes midway between the slits to the first maximum and the line that goes straight across. This angle right here. So now we can get the distance between the central max and the first max on the screen, the distance between the bright spots. Tangent of this angle is the y position, the vertical position, divided by 1.2 meters. Opposite side is y, the adjacent side is 1.2 meters. Substituting in the angle we found earlier, we can solve for y. The distance between the bright spots, 3.01 millimeters. And that's the answer to problem 2.